The Periodic Table by John Lewis Peralta. In this whole wide world there exists this one table. Not the furniture kind, and not a math table either, but a science one, a chemistry one to be exact. It's called the Periodic Table. The Periodic Table, or PT for short, is made up of all the elements in the entire world. They're everywhere. The periodic table is easier to understand than it looks. It's separated into groups or families just like people. The periodic table also has a special name for its columns. When a column goes from top to bottom, it's called a group. They go from 1 all the way to 18, and as you go down each element or atom in a family, one energy level is added. Now in the PT, you can find 3 types of elements: the metals, the nonmetals, and the metalloids. Almost 75% of all atoms are classified as metals. They are not all like silver, gold, or platinum. Those are the very cool and shiny ones. There are other metals, like potassium and magnesium, that you might not think about right away. Nonmetals are some of the most abundant elements in the universe, including the Earth's crust, the atmosphere, and the human body. The elements that are generally considered nonmetals include hydrogen, carbon, nitrogen, phosphorus, oxygen, sulfur, and selenium. A metalloid's properties are in between the metals and nonmetals. There is no unique way of identifying them, but the most common way is that metalloids are semiconductors rather than conductors, which is something that can create electricity. They're the green ones in the picture. Now all these metals, nonmetals, and metalloids are put into even smaller categories. These categories are alkaline metals, alkaline earth metals, groups 13 through 16, halogens, and noble gases. And then of course there are the transition metals, which are found in groups 3 through 12, and the inner transition metals down at the bottom. Every element on the PT has at least one electron, the negatively charged part of the atom. When pairing up with other atoms or elements, each atom's goal is to gain or lose enough electrons to have 8 valence electrons in their outermost shell. This is called the octet rule. What are valence electrons? They are the electrons responsible for bonding and are found in the outermost energy level of the atom. You can find how many valence electrons one atom has by looking at the number in the group's ones place. For example, an element in group 16 would have 6 electrons. Each of the elements on the PT has an atomic number, the amount of protons, a positively charged particle, are in the nucleus of that atom. The periodic table has some trends, just like we do. We have fashion trends and technology trends, while the PT has 4 trends: atomic radius, ionization energy, electronegativity, and reactivity. The first one, atomic radius, is basically just the distance between the nucleus and the outer shell, where those valence electrons lie. Across the PT, as the atomic number goes up, the atomic radius goes down, but when going down a group, the atomic radius goes up. The next trend is ionization energy, which is the energy needed to remove the outermost electrons, or the valence electrons. From left to right, as the atomic number goes up, the ionization energy goes up right with it, but from top to bottom, the ionization energy decreases, or goes down. The third trend of the periodic table is electronegativity. Electronegativity is a measure of an atom's ability to take another atom's electrons. When going left to right, as the atomic number increases or goes up, the electronegativity of the atom goes up as well. But when going down or top to bottom, as the atomic number goes up, the electronegativity decreases. But wait, noble gases are not included. Can you guess why? Because noble gases already have 8 electrons. Don't you remember the octet rule? Last but never least is reactivity. Reactivity refers to how likely an atom is to react with other substances, depending on how easily electrons can be removed and how easily atoms can be grabbed. For metals, from left to right, as atomic number increases, reactivity decreases. And vertically, as atomic number increases, reactivity decreases. But for nonmetals, it's the complete opposite. It's that simple. As far as we know, there are only so many basic elements. Up to this point in time, we have discovered over 120. While there may be more out there to discover, the basic elements remain the same, and they're all collected and put in the periodic table. Now that you know a little or a lot on the periodic table, go out and share your newfound knowledge with friends and family. Show them what you've learned.